This is Mrs. Fackler. This is Honors Pre-Calculus Exam Review, question number 1. It's asking for the equations of asymptotes and coordinates of any intercepts and to graph the function. You can see the graph of the function is over to the right. I'm going to justify that graph by factoring. And we have a vertical asymptote at x equals 5 and at x equals -2. We have a horizontal asymptote at y equals 0 because the numerator's power is higher in the denominator than it is in the numerator. And we have a y-intercept at 0, -3/10. When we substitute 0 in for x, you can see that we end up with a 10 in the denominator and a -3 in the numerator. As we graph it, you can see that we've graphed both the vertical asymptote at -2 and at 5 with a horizontal asymptote at y equals 0, and we have the intercept approximately right here. Number 2, I'll use the same procedure again. I'm going to factor the denominator. I have a vertical asymptote at x equals -4. At x equals 2. I have a horizontal asymptote, again at y equals 0, since the denominator's power is higher than the numerator. I have an x-intercept when I substitute 0 in for y at 4. And I have a y-intercept when I substitute 0 in for x at 1/2. As you can see, they both have been graphed over here, and we are crossing the asymptote, which is entirely possible. Horizontal asymptotes indicate end behavior. Going on to number 3. Number 3, I do not need to factor, but I recognize that I have a vertical asymptote where the denominator is undefined at x equals 3. I have a horizontal asymptote at y equals 2, and that's indicated by the fact that I've lifted up my graph 2 units. I have an x-intercept at 1/2 0 by substituting 0 in for x. And when I substitute in x-intercept at 1/2 0, where I substitute 0 in for y, and now I'm substituting in 0 for x, and I get a y-intercept of 1/3. Moving on to number 4. Number 4, I'm going to factor again. I end up with x minus 6 times the quantity x minus 1 over x minus 6 times the quantity x plus 6. You can see that I have a removable discontinuity at x equals 6. And when I substitute 6 into the equation, I end up with 6 and 5/12. I have a vertical asymptote at x equals -6. And I have a horizontal asymptote at y equals 1. And that's because the power of the numerator and the denominator match, so the coefficients indicate what the horizontal asymptote would be. I have an x-intercept of 1, 0 when I substitute y equals 0. I have a y-intercept at 0, -1/6. I have a domain of all reals except x cannot equal 6 or negative 6, and my range would be all reals except y cannot be equal to 5/12 or 1. And you can see the whole is indicated in my graph along with the asymptotes as dotted lines. Number 5, again, I'm going to factor. And I see, in this particular case, that because the power is higher in the denominator, that I have a slanted asymptote instead of a horizontal asymptote. So I'm going to use synthetic division. And just to remember, you bring down the 1 and you multiply, and you add, and you multiply, and you add, and I end up with a slanted asymptote at y equals 1x or x minus 2. And remember that my remainder goes to 0 as the function moves out to the ends of the graph. I have a vertical asymptote at x equals 6. My domain would be all reals, except x cannot equal 6. I have a range of all reals. My x-intercept will be 1, 0, and 7, 0. And my y-intercept will be 0 and negative 7, 6. Now I have to determine which is the following of the following is the equation of the horizontal asymptote. I can see that the power of the numerator and the power of the denominator of the leading powers are the same. So that means that because they are matching, it would be the coefficients of my leading powers, and that would be y equals 4, and my selection would be D. In number 7, solve the equations and check for extraneous solutions. So I'm going to factor and find my greatest or least common denominator. I can see that my least common denominator will be x minus 1 times x plus 1. So I'm going to multiply the first equation by x plus 1 over x plus 1. On this side of the equal sign, this has the least common denominator, but I need to adjust this one by multiplying both by x minus 1 and x plus 1. If I multiply both sides of the equation by this denominator, it will cancel. And it leaves me 3x times the quantity x plus 1 equals 12 plus 2. And if you multiply this out, this is x squared minus 1. This becomes 2x squared minus 2. I'm going to distribute this, gather like terms, set this equal to 0 to solve, and factor. Setting each factor equal to 0, I find that x is equal to -5, or x is equal to 2. But I need to check my denominators for extraneous solutions. But there are no extraneous solutions because if I resubstitute either one of those x values in the original equation, everything is fine and I have no problems. Moving on to number 8. Number 8, I'm going to follow the same procedure. I can see that the least common denominator will be x minus 4 times the quantity x minus 2. So the first equation needs an x minus 4 factor. The second equation needs a factor of x minus 2. And the third, on the other side of the equal sign, has the correct denominator. Again, multiplying both sides of the equation by x minus 4 times the quantity x minus 2, the denominator will cancel. That will leave me x times x minus 4 plus 3x times x minus 2 equals 32 minus 2x. I have x squared minus 4x plus 3x squared minus 6x equals 32 minus 2x. After I gather like terms, I'm left with 4x squared minus 8x minus 32 equals 0. There's a GCF of 4, so I'll take that out before factoring. And it factors into x minus 4 times the quantity x plus 2. And I will have solutions of 4 and -2. I look back at the original equation to see if I have an extraneous solution. And although -2 does not put a 0 in the denominator of the function, x equals 4 does. X equals 4 is extraneous. And x equals -2 is the solution to the problem. Be solving the inequality for 9 and 10. I can see that I have a vertical asymptote at x equals 2. Because it's an inequality, I have test points that I have to test. So I'm going to be testing 0 and 2. So this would be my 0. This would be my vertical asymptote. These would be interruptions on the x-axis. When I substitute a number less than 0 into this equation, I end up with a positive value. When I substitute an equation between 0 and 2, for example, 1, I end up with a negative value. And when I substitute a number greater than 2 into the original equation, I end up with a positive value. So I can see that because this is telling me that the function must be less than 0, it would be values here between 0 and negative 2. So my solution to this equation would be 0 is less than x, which is less than 2, and there's no equal sign here because there is no equal sign here. This concludes part 1.